Magnets. You just can't get away from them, especially if you're made of iron. They are everywhere, from your headphones to your PC to cash at the cash point. In fact, magnets are the little scientific secret behind almost every clever device you can't do without. But when it comes to making the attractive little fellas, how do they do it?
You're looking at the biggest magnet on the planet. It is the planet. 1,800 miles below the surface, the Earth's outer core is a vast 1,300-mile wide churning ball of liquid iron and nickel. The circular movement of this mass of molten iron creates the Earth's magnetic field, which makes compasses point north. But the Earth's magnetic field is still quite weak. A simple magnet like this produces a magnetic field 200 times stronger than the Earth. These bar magnets are made from a special iron alloy that's been exposed to a powerful magnetic field. The atoms inside have realigned themselves, creating permanent north and south poles. But if you want a really powerful magnet, then you need an electromagnet like this. 200 times more powerful than a simple bar magnet, it can temporarily magnetize other metals until you turn the power off. In fact, if you've got a strong enough magnetic field, you can affect almost anything. It doesn't even have to be metal. Here, a powerful magnet is actually levitating a strawberry. Of course, to make floating strawberries, you need a really, really powerful magnet. They don't come more powerful than the magnets here at the Mag Lab just outside Tallahassee, Florida. In this building are the most powerful magnets in the world. Scientists here are using their super mighty magnets to do all kinds of stuff, from developing new forms of transport to revolutionary new medical treatments. For groundbreaking research like this, you need magnets that offer precision and power, and an off switch wouldn't hurt either. MagLab boss Mark Bird is strangely drawn to magnets.
I can talk about magnets all day.
Mark explains how his magnets work using an ordinary household nail.
You take a nail and you take some wire, you wind it up, you stick a battery in here. And now what happens is current flows through this wire. It goes around and around in circles. It makes a magnetic field in the center. And now we can pick up paper clips with it.
The key to Mark's electromagnet is not the nail in the middle. It's the spiral of electric current running around it that whips the atoms of whatever's in the middle into line. But here they don't like messing around with little magnets. They like working with big, super powerful and slightly scary magnets. In the heart of the building is the biggest magnet ever built, the 45 Tesla hybrid magnet. It's so powerful that just being in the same building as this thing wiped clean half our camera tapes, which was extremely annoying.
So magnetism is when atoms or subatomic particles like to line up in a particular way when squirted with an electric charge. Sort of. Clear? Well, never mind. Here's a magnet so utterly humongous, it could rip out your fillings from half a mile away.
The 45 Tesla is 4,000 times more powerful than the one Mark demonstrated earlier. But if it was 4,000 times bigger, it would be 1/4 of a mile long. The key to making a really powerful magnet is making it compact. And the way they do that is by using loads of magnets to magnify each other's magnetic fields.
This is the core of the 45 Tesla hybrid magnet, the most powerful DC magnet in the world. There's 5 coils. You see 4 here because there's actually 2 nested here that you can't really see. So this is an insulator, goes around the first coil, and then these go inside the second coil, another insulator, the third coil, another insulator, the fourth coil there.
If you just ran electric current through one of these coils, it would make a powerful magnet on its own. But when they're stacked inside each other like Russian dolls, each coil is boosted by the bigger coil outside, creating a massively amplified magnetic field. It's a clever idea, But making it work requires superhuman patience. Fortunately for MagLab, Jim here is possibly the most patient man in Florida. Putting together the thousands of metal plates for the coils that generate the magnetic field takes Jim 6 months. If he just stacked the 0.2mm thick copper sheet in layers, the current would travel straight up, and no spiral means no magnetic field. So Jim places fiberglass insulation on either side of the copper sheets, slowly building an incredibly dense spiral.
So what the insulator is doing, it's stepping around the coil, and it's acting like a spiral staircase. You take that off, and there you go. You have another turn on a resistive magnet. Hey, let's go build another one.
The 45 Tesla hybrid turned out to be too much magnet even to look at safely. But we did manage to film its little brother, the resistive magnet. Inside its steel casing, copper plate coils, exactly like the ones we saw Jim make, exert a magnetic field 400,000 times more powerful than the Earth's. It's a valuable tool for research, and when the boss isn't looking, it's good for party tricks too. So, just for how do they do it, they showed us a neat little bit of magnetic magic. Our glamorous assistant, Tim Murphy here, drops a chunky 2-kilogram aluminium tube into the top of the machine at 6 p.m. The intense magnetic field induces a current inside the tube, creating an opposing magnetic field. The two fight it out, slowing the tube's fall. When it finally hits the floor 12 feet below, it's 6:02. 2.5 minutes have passed. Not magic, of course, just magnets.